Density problems can be solved very much like percentage problems. The important definition here, remember the density is given as a mass over volume. And so if somebody were to give you a statement such as the density of gold, and AU is the chemical symbol for gold, is 19.3 grams per cubic centimeter, that's a mass over volume ratio. Before you start solving problems with this given density, it would again be a good idea to write down explicitly what that means. This means I have 19.3 grams of gold for every 1 cubic centimeter of gold. And just like those percentage conversions, I can also write this the other way around. 1 cubic centimeter of gold is the same thing as 19.3 grams of gold. As always, conversion ratios can be written one way or the other. Which way you write it depends on what your given values are and what you're trying to convert something to. So for example, if somebody wants to know how many cubic centimeters of gold is equivalent to, let's say, 95.3 grams of gold, the conversion ratio will have to be written so that grams of gold are down below. So the given here is 95.3 grams of gold. And clearly I have to use the ratio that says cubic centimeters of gold over grams of gold. And the arithmetic here works out to be 4.94 cubic centimeters. Notice, by the way, the density is a measured quantity, so its sig figs count. And I also gave you 3 sig figs in the 95.3, so I should have a 3 fig estimate. Remember, this is the multiplication rule on sig figs. I count sig figs. I don't look at degree of precision. Both the given values here are to the nearest tenth and the answers to the hundredths, but that has to do with the fact that I'm counting sig figs in a multiplication or division type problem. Again, none of this is difficult to do if you write the units. I see that's the most common mistake people make, is they fail to write the units. In number B, I might ask, for example, how many grams of gold are equivalent to 75 cubic centimeters of gold? And again, it's the same strategy, except I'm going to be using my ratio the other way around, because I'm giving you now cubic centimeters of gold. And the numbers here are 19.3 grams of gold is the same thing as 1 cubic centimeter of gold. And so the answer here comes out to 1,400 grams of gold. Notice in this case, the given value was 2 sig figs. The ratio was 3 sig figs. So I give a 2 sig fig answer. I'm holding 2 placeholding zeros. Put 2 placeholding zeros there because I don't want to write 14 grams. I want to write 1,400. If I wanted to write this in scientific notation, I could write 1.4 times 10 to the 3 grams of gold, and then I would have been much more explicit. Those zeros wouldn't be ambiguous for me at all. It's very clear in scientific notation. Number C, I'm going to give another question here that involves 2 conversion ratios and ask, for example, how many cubic centimeters of gold are in 195 grams of alloy that is 25% gold. Again, as I've been stressing, one thing I should write here is that the percent means I have 25 grams of gold for every 100 grams of alloy. That's what percentage means. I'm going to use 2 conversion factors here. I've been given 195 grams of alloy. Notice I can't apply a density of gold to grams of alloy because alloy doesn't cancel gold. That's the essential idea of writing down the names of everything also, not just the numbers, or need for that matter, not just grams or cubic centimeters, but also grams of what? So if I have 195 grams of alloy, I can certainly find out how many grams of gold that is, because it's 125 grams of gold for every 100 grams of alloy. Notice grams of alloy are cross-canceling. The question wasn't how many grams of gold, it was how many cubic centimeters of gold. So I apply a second ratio. A cubic centimeter of gold is the same thing as 19.3 grams of gold. And when I do that arithmetic, it comes out to 2.5 cubic centimeters of gold. Again, like everything else, you write all the units if you want to have these problems work out easily and give you the right answer.